Good morning. Good morning. Good morning. Hi there. Good morning. Happy Monday. Happy Monday. Good to see everybody. Some of you did not do your exit ticket, or you're due now, and if you did, you didn't send it to me, so make sure you DM your due nows before class so I can give you credit for having done it before class. Hi, honey. Good morning. I want to be able to give you credit for doing things ahead of time and not just copying what we do in class. So even if it's wrong, I just want to see that you made effort on the do nows, okay? Like today's do now was something very simple that you've done before. And then there was one that was a little bit harder that we're going to go over. So good morning. It's 9:58, so we're waiting. Good morning, Ms. Mixon. So I was just telling everybody as you sign on, people are not sending their do nows and exit tickets at the rate that they were before. So people have stopped doing that. I'm not sure why, because like we've all told you, fourth quarter matters. Okay, term 4 matters. And if you want to keep raising your grades, that's the way to do it, is to be doing the work. This math work is all new. Good morning, good morning. This math work is all new, and you're going to need it for 7th grade. So we're trying to get you ready so that you don't feel like you're behind next year. This isn't just review. Some of the skills are review from prior grades, like 5th grade, but now we're building on them. Okay, so for example, one of the do now questions this morning was the area of a rectangle, which is a 5th grade skill that you already know. But now it's using fractions, and it's actually working backwards from having the whole area to determining what the length or width is. So that's how they take a skill you learned earlier and turn it into a higher skill. Okay, because now you're using multiplication and division of fractions, which is a 6th grade skill, and applying them to a formula that you learned earlier, and the working backwards part. Good morning, good morning. So it's 10 o'clock, but let me flip it around so you can see. So this was one of your do now questions. This is the page we're on, because I know I'm going to get questions about that. Okay, if you have the packet, we're working from the packet that's distance learning 4 and 5. So today we're finishing the last day of week 4, and tomorrow, I guess Wednesday, we'll be using the week 5 work and doing day 1 of week 5. Good morning, good morning. So if you already turned in this packet, say by mistake, or you didn't get this packet, you can download the problems or look at the problems in Teams or in Canvas. So everybody has access to it somehow. You can also always DM me your email address. I've emailed it to people, okay? But there's no excuse not to have the work, because we're making sure everybody has what they need, and there's lots of different ways to get it, okay? So this was the day 4 lesson that we're on, and the opening was your do now, okay? So today's objective is that by the end of the lesson, I will be able to find distance, perimeter, and area in real-world contexts. So this is always a fun day of the lessons when they take things we've learned, like distance, perimeter, and area, and they apply them to real-world problems, okay? So you should have already done A, okay? That was one of your do now problems. Find the area and perimeter of this rectangle, and they gave you 2 sides. They gave you a length of 9 centimeters and a width of 5 centimeters, okay? So you had to figure out the perimeter and the area. So when you send me your DMs of that paper, your photos of that paper, I'll see what you wrote for that answer. And then this was the one that was a little more intricate, and you had to apply knowledge from all the different lessons that we've been doing throughout the year and even last week, things that we talked about. So I'm going to show you how to do this one, because this is definitely the kind that shows up on park tests and unit tests, and it's one of the skills that you definitely want to know how to do. Good morning, good morning. We're getting a lot less people now, and it's interesting because, again, if all of the grades are just going to help you, I'm not sure why people wouldn't want to be participating. So, find the width of this rectangle. The area, good morning, is 7/8 meters squared, and the length is 1/2 meter. Okay, they drew a picture. They've already calculated this interior space of the rectangle. They're telling you that the area is 7/8 meters squared. Okay, they're telling you the length is 1/2 meter, and they're telling you that they want you to find width. So they gave you the variable W to stand for width. Good morning. They also even reminded you that the area of a rectangle is length times width. Good morning. Okay, so all you're doing is using that formula, okay, filling it in with information that they've already given you in the problem, and then trying to determine what's left that you need to solve for. So this then works into our unit that we just finished before this one on expressions and equations, because this is an equation, area equals length times width. That's the equation to find the area of a rectangle, okay? So we also call it one of your formulas. But it is not on your formula sheet for 6th grade because you're supposed to already know it. And then we used the information they gave us to work backwards. So you're going to have 7/8 meters squared. We need the units too. And then 1/2 times W. And they used the little dot for W. I mean for multiplying. Okay, so in this case, we know with things that we did in our the skills we used in expressions and equations unit, that the goal in these equations then is to isolate the variable. We have to isolate it, which means to get it by itself. Okay, right now it's being multiplied times W. I mean times 1/2. And we know that we can get rid of the dot and just write them next to each other, and that means 1/2 times W. And then I'm gonna rewrite the 7/8 just right now without the units, but I don't want to forget the units. Okay, so we had talked about how what we have to do to isolate is use inverse operations to get all of the numbers onto the other side of the I think we called it the river in 7th grade, Mr. Taylor calls it, so that's the terminology we were using. But we want to use inverse operations to separate 1/2 from the variable and get it on this side with 7/8. So the inverse operation of multiplication is division. So that's what makes it a 6th grade skill, is that we're doing division. I'm making this line a little bigger so you can see. So we're dividing by a fraction. So the minute you see that we're dividing by fractions, that's where we get into the 6th grade skills. Okay, so that's where it gets, you know, a simple area problem at the 6th grade level. So, and again, we're going to go over the rules of dividing fractions, but right off the bat, we know anything divided by itself is 1, right? So the 1/2 divided by 1/2 gives you your 1, and we always put that invisible 1 in front of the variable just to make it easier. And then we have 7/8 divided by 1/2. Okay, so we know though that we don't just divide fractions, and I'm going to rewrite it. 7/8 divided by 1/2 out to the side. Okay, we learned that with fractions you multiply by the reciprocal. Okay, so this is where some of you came in from 5th grade and said you knew keep, change, flip, and you used that little memory device to remind yourself what to do. Okay, but we keep the first one the same, and then I liked to say we multiply by the reciprocal of the second one, and the reciprocal is when we flip this fraction. So we have 1/2, and then we changed it to 2/1. Okay, then we simply solve it the way we learned to multiply fractions, right? Numerator times a numerator. 7 times 2 is 14. 8 times 1 is 8, right? You're just multiplying the same as we learned, but we have an improper fraction. Okay, So we're going to have to reduce that. Okay. And if I'm looking for a number that goes into both, maybe to start making it easier before I divide, I could divide it by an equivalent fraction, something equivalent to 1, that is 2 over 2. So 14 divided by 2 is 7. 8 divided by 2 is 4. That's still improper. So we're going to do our regular division problems. 4 goes into 7 one time. 1 times 4 is 4. I'm still using the Does McDonald's sell cheeseburgers as my memory device for dividing. So after the multiplication step, I have 7 minus 4 is 3. I'm going to use the remainder as my numerator and my divisor as my denominator. And I have 1 3/4. Okay, so 7/8 divided by 1/2 would be 1 3/4 meters. Because this was meters squared divided by meters, which we said there's that invisible 1. And when you take meters squared and divide it, you get another meter to the first power. So that's how we get 1 3/4 meters. Okay? So that would have been your answer to the do now. Okay? Are there any questions about that one? If you have questions, type them in. Any questions? Okay? So that means this width Oh, can you hear me? Sorry, it disappeared. Okay? So, no questions? Sorry, my screen froze. So, now we're going to talk about our new learning. Good morning, good morning. Good morning, everybody. So, this is the part that has your new learning. Okay, that's what they're calling it in these packets, so that you know what the new information is. The do nows are always, just like we do throughout the year, the do nows are the information usually from your prior lesson. Okay, so it says, today you'll be applying what you know about geometry to solve real-world problems. Before jumping into today's lesson, please review the formulas below and the examples provided. So this is what I asked you guys to read ahead of time when it said to read the lesson. The page in this packet is, let me see at the bottom of the page. It says 2 of 5. I don't know if your packets are paged, because that's day 2. It's page 2 of this day 4 lesson. So mine doesn't have all of the page numbers overall. If somebody could tell make in the comments what page it is overall in the huge packet, because mine just says it's on page 2 of 5. Because when they send it to the teachers, I think they sent it differently. Like, I don't have all your ELA stuff and science stuff and all that. So that might be why mine's also numbered differently. The area of a triangle, we learned, I think, in prior grades, but we've reviewed both of these. The area of a rectangle or a parallelogram is the same. That area equals base times height. And the area of a triangle is 1/2 multiplied by the base times the height. And we've also talked about how you can take the base times height and divide it by 2. We just reminded ourselves from the beginning of the year in 6th grade that multiplying by a fraction is the same as dividing by, thank you, Ms. Mixon. It's page 31 out of 34 pages, if you have it that way. I'm sorry, mine's a different page than you guys have. So it should be nearing the end of week 4. Okay, and so this was a reminder about how to calculate the area of the parallelogram, remember to find the height. Sometimes they have the height on the outside of it. They can draw it inside, but sometimes they're trying to make it a little trickier and they draw it on the outside. You also learned, again in these lessons the last couple weeks, that the height meets a line that's at least in line with the base at a 90-degree angle. Okay? So this is not the base of this shape, so you won't use this part if they give you a value for that. You're welcome. Thank you for asking. I'm sure other people had that question about the page number, so thank you. This is the base of this parallelogram, and the height would be this, if I drew it and just slid it down over here, would be a straight line up and down that meets at a 90-degree angle. It is not this slanted piece. Okay, so that's what they're just reminding you, that the base is the 5 5/6 centimeters, the height is 1/7, and that you can use those and substitute those values into the equation for the area. Let me raise it up for you. I don't know if you guys can see over the comments. So they used the formula for the area of a parallelogram, which is the base times the height. They put in the base number, 5 5/6, and the height number, 1/7. Now, we also reviewed this year, even though it's an earlier skill, that you take the whole number and multiply it by the denominator. 5 times 6 is 30, and then you add the numerator, so 30 plus 5 is 35, and you put it over the same denominator. And that's how you go from a mixed number to an improper fraction. Okay, so that's where they got 35/6. They took 5 times 6 is 30 plus 5 and wrote it over the same denominator. Okay, then all they're doing, multiplying fractions, just involves multiplying numerator times numerator. 35 times 1 is 35. 6 times 7 is 42. Good morning, good morning. And a centimeter times a centimeter is centimeter squared. Okay, so that's your review of using the area of a rectangle or parallelogram. That should really help you, because parallelograms were new this year, and now that you oh, that's very nice. Thank you, honey. Somebody's sending me a message. Now that you know they're the same, it's like there's one less formula that you have to worry about knowing. And then you have the area of a triangle. Okay? Then they wanted us to review finding the area of this triangle. Now, this looks more like one they would give you in testing. They have a distance here. A length of this is 9.85 inches. Then they have this part is 9 inches. They have this part is 3 inches. They have a dotted line with 4 inches. And then this hypotenuse of this other triangle is 5 inches. So it says to determine the area of the triangle, I need to know the base and the height. The base of the triangle is the sum of 9 inches and 3 inches. Okay, so could you find the area of this little piece and this little piece and add them together? Sure, but why would you waste your time? This you can just count as one big triangle. So if you add these two lengths together, this would be the base of your big triangle, and this would be the height, because this line comes down and meets the base at a 90-degree angle. So that's what the square, remember, designates, that that's a right angle, which equals 90 degrees. And then they used the numbers in the formula. 1/2 times the base of 9 plus 3 is 12, times the height of 4 inches, which they gave you in the problem. And 12 times 4 is 48. So they're kind of missing a little step here. You would have 48 divided by 2, and that would give you 24 inches squared. Okay? You could also multiply the 1/2 times 12. What is half of 12? 12 divided by 2 is 6, and then 6 times 4 is 24. Okay? Remember, you can multiply in any order, because multiplication is a commutative property. It means you can move the numbers around and you'll still get the same answer. So you have that flexibility. Okay, so this part of the assignment, it said today we would fill in the area and perimeter of objects and items in your real life. So they've given you this table, and they gave you even a little ruler if you have the packet at home that you can cut out. So what you're going to do for credit is measure, they want you to measure something. This says desktop. If you have some kind of table or desktop at home, you'll be measuring that. They want you to do something that's rectangular in shape. They want you to measure something that's triangular in shape at your house, and then one that's your choice, okay? And then you can fill in the table. So if you do this assignment, this part of the assignment, I believe this is going to count, this project is going to count as an extra credit project towards your grade for fourth quarter. So Ms. Mixon and I will be talking about that more during her class and my class, especially if people have measurements of something in their house and they want help solving that and filling that in. Okay? So the other problem that we're doing today that was a little bit lengthier was this one about the painting. Okay? Good morning, good morning. So I'll read it to you just for time's sake. Usually I like to have people read some of these and participate that way, but this is a really long problem, so I want to make sure that we get it all in. A homeowner called in a painter to paint the walls and ceiling of one bedroom. His bedroom is 18 feet long, 12 feet wide, and 8 feet high. The room has 2 doors, each 3 feet by 7 feet, and 3 windows, each 3 feet by 5 feet. The doors and windows will not be painted, because they're just like holes in the wall, really. That's how we're going to think of them. A gallon of paint can cover 300 feet squared. A hired painter claims he needs a minimum of 4 gallons of paint. Okay? Show that his estimate for the number of gallons is too high. Okay? So, that's what we're going to do right now. And they've given us these nice tables to organize all this information because they gave you so many numbers. Because again, if we were doing this on a test and underlining, we'd want to make ourselves a little bit of a table and label, just like we do with our, longer word problems. You want to label the parts and underline. So his bedroom is 18 by 12 for the length and the width, and 8 feet high. Okay. There's 2 doors that are each 3 feet by 7 feet, and there's 3 windows, okay? And we're not painting the doors and the windows. So, this first table says find the area of the frame of the house. And they've told you what that includes. That's 2 walls that are long, okay? Those are the long walls. The 2 short walls in the room, and then the ceiling. Okay? So, any questions so far about which problem you're on? Okay, and you're going to be writing your answers in the table, but remember you have to show your work. That's one thing that I have to say has been a little disappointing with people turning in packets, is people aren't showing all of their work. And remember, that's what we're grading you on, is the work. We're not just looking for right answers. Okay, it's about, did you understand the process and how to do it so you could do it again yourself on some other thing. Okay, so the 2 long walls, they said were 18 feet long and 8 feet high. So they're multiplying 18 times 8, and then they're multiplying it by 2 because there's 2 walls that are that size. Okay? Now, on a problem like this you'd be allowed to use your calculator. We talked about having a calculator some of the time. So, if I have 18, I'll even use my calculator, times 8, I get 144. Okay, so that's multiplying 18 times 8, but then I still have to multiply that by 2. Times 2, 288 feet squared. So that's where they got that answer. Okay? So we have 2 long walls. Then we have 2 short walls, the walls that are 12 feet long by 8 feet high. So I'm going to take 12 times 8. Oop. 12 times 8 is 96. And I have 2 of those short walls. So I'm going to multiply that by 2. And I get 192 feet squared. Okay? So in this box, where they don't have anything, you're going to write 192 feet squared. Okay? Then we have the ceiling. So I'm going to write my 288 feet squared. My short walls, excuse me, is 192 feet squared. And then I'm going to have my ceiling. Okay? What am I multiplying to find the length and width of my ceiling? Which numbers? You're going to type those into the comment. Okay? I have 2 long walls, 18 feet long. I have 2 short walls, 12 feet wide, and then 8 feet high. Those are 3 numbers they gave. Which of those numbers, am I using to determine the area of the ceiling? Look up at the room you're in right now. Look at your ceiling. Would you be multiplying the length and width of the room? Would you be multiplying the length times the height of the room? Would you be multiplying the width times the height of the room? Which numbers are you multiplying? So you're going to type those into the comments. Which of the 3 numbers, 18, 12, and 8, are you going to use to figure out the area of the ceiling? You're going to use the height of a room to figure out the ceiling? Don't just copy what somebody else wrote. Okay? So let's think of this. If we're finding the area of a room, and we always think of like the floor, and the length is 18. The length of the room is 18. Yes, we're going to multiply it 12 times 8. You need the length and the width. Just like if you were finding the area of the floor, you're using those same numbers, right? The ceiling is just a mirror image of your floor. So good job. Yes, sir. So you're going to take 18 feet times 12 feet. Now, are there 2 ceilings? Do we need to multiply it by 2? Give me a Y for yes or an N for no. When we multiply this to find the ceiling, do we also need to multiply it by 2? Are there 2 ceilings? Give me a Y for yes or an N for no. Think about your room. Look up at the room you're in. Good. Okay, think about the room you're in. Are there 2 ceilings in your room? No. No, exactly. No. You have 1 ceiling, sillies. You have 2 long walls and 2 short walls and 1 ceiling. Okay? So, 1 ceiling. We have 18 times 12. So, 18 times 12 is 216 feet squared. Okay? So, this is the area of 2 long walls, 2 short walls, and a ceiling. So to find the area of the frame, remember this was the area of the frame of the house, what do I need to do with these 3 numbers? You can type it into the comments. What do I need to do with these 3 numbers? Type it into the comments. Don't just copy what somebody ahead of you puts. If I'm trying to find the area now of the whole frame, I have the area of 2 long walls, the area of 2 short walls, and the area of a ceiling. What am I going to do with those numbers? Don't just copy what other people are saying. So you think I would multiply. I'm going to take the area of the two walls and multiply it by the area of the short walls and then multiply it by the area of the ceiling? Think about that. You're finding the area of the frame of the house. Okay? 2 long walls, 2 short walls, and a ceiling. We just found the area of all 3 things. Are we going to add, subtract, multiply, or divide them to find the total area of the frame? No, we're not going to multiply. Okay, well, hold on to your final answers. We'll go over those in a little bit. Addition, yeah. We're not going to multiply or divide. If you're trying to find the total area of something, no, we're not going to subtract. Nope, we're not going to divide. You're going to add. If you want to find the total area of these 3 areas, you have to add them together. Right? You have to add them. Nope, we're not going to subtract. I keep hitting time on this. I've never seen a calculator with time. Nope, we're going to add them. Why? Because we're finding a total area. 288 plus 192 plus 216 equals 696 feet squared. We're adding feet squared so it stays feet squared. Yep, we're going to add. Thank you. We're adding. Okay? So that's the area of 2 long walls, 2 short walls, and a ceiling without taking into account doors and windows. But we know there are doors and windows. Part 2 said, find the area of the doors and windows. These represent areas that do not need to be painted. They have it in italics. Yeah, you don't just paint over your windows, right? You wouldn't be able to see out. So, they gave you the measurement of the 2 doors. Back in our problem, if you have your hard copy, you should have underlined that the room has 2 doors, each is 3 feet by 7 feet. And the 3 windows you would have underlined was 3 feet by 5 feet. Okay, so that's where the numbers came from. So, 2 doors that are 3 feet times 7 feet. Good morning. 3 times 7 is 21. And then there's 2 of the doors. That's why they're multiplying it by 2. So 21 times 2 is 42 feet squared. That's where they got that number. Then they said there's 3 windows. The measurement of the windows. Yep, the measurement of the windows was 3 feet times 5 feet. 3 times 5 is 15. Ms. Mixon and myself have told you that 15s are one of those numbers that even though you might not have learned your multiplication tables all the way to 15s, the 15s are really, really, really useful to know your multiples and be able to count by 15s because so many problems in 6th grade and 7th and 8th grade use 15s. 15s, good morning. So 3 times 5 is 15 and 3 times 15 is what? Type in your number in the comment section. We're doing 3 times 15. I'm just writing this while you're writing that. We have 2 doors, 3 windows, 42 feet squared is the area of the 2 doors. Good. 45, don't forget your feet squared, is the area of the 3 windows. 3 times 5 is 15. 15 plus 15 is 30. Plus 15 is 45. Okay, good job. So, now we have the area of the doors and windows. Okay. What are we going to do with those? To find the total area of the doors and windows, just like we did above. Are we going to add, subtract, multiply, or divide? The 4 operations. What are we going to do to find the total area of doors and windows? Okay, because it wants us to find the area of doors and windows. That means together. So this is them individually. What are we going to do? Add, subtract, multiply, or divide these two numbers. If we subtract 42 minus 45 or 45 minus 42, I think you're talking about the next step. What are we going to do with these two first before we get to subtracting them? Good. Adding them together. So 2 plus 5 is 7. 4 plus 4. I'm reading people's comments, sorry. Is 8. Okay. This is our total area of the doors and the windows together. Okay. That's the area of the doors and the windows. This is our total area of the long walls, the short walls, and the ceiling. Great. That's awesome. So she said you're going to take the doors and windows and subtract them from the total area of the walls and the ceiling. That's exactly right. That's exactly right. So we're going to take 696 feet squared. Somebody's asking what page. This is the last page of day 4 of the week 4 packet. On Wednesday, we'll be starting day 1 of week 5. So we have the total area of the 2 big walls, the 2 little walls, the ceiling. We're subtracting out the area of the 2 doors and the 3 windows. So this is how we would find our final answer. Thank you. Somebody says it's page 33 and 34 that we're on, for people just jumping on. Okay, so you can type in your answer. What happens? What do you get when you subtract these? I'm going to use my calculator to see if you're right. And then we're still not even done with the problem. Thank you for helping each other out. I appreciate you telling people what page we're on. So go ahead and type your answer in for 696 minus 87. Good morning, good morning. Go ahead and type in your answer in the comments for 696 minus 87. Yeah, some of you might have to rewrite it like this. Okay, but I want to see what you get as your answer. Good morning. We're looking for the answer of the total painted area minus the area, equals the area of the frame, minus the area of the doors and windows. Okay, we're on this step, part 3. We have the total painted area, 696 feet squared, minus the area of the doors and windows. So I'm looking for people's answers. Great job. That's what I got. 609 feet squared. Now, if this is a part question, am I done? No, ma'am. No, sir. That's just part 3. That's the total painted area of all of the walls and ceiling, the whole frame, they're calling that the frame, minus the area of the doors and windows. What we're trying to do now is find out if we're going to get cheated by somebody giving us an estimate for too much money on our paint. Because it said find the number of gallons of paint needed. And up here, I believe the gentleman that wants to paint our house, this painter claims he needs a minimum of 4 gallons. Well, paint's expensive, so we don't want to get more gallons than we really need. So it says, find the number of gallons of paint needed. So we need to know the gallons of paint needed, which we just found, and divide it by 300. Now, where did they get 300? Right in our problem, like we said, we would have underlined a gallon of paint can cover 300 feet. 300 feet squared. That's area, 300 feet. 300 square feet. Okay, so what number is going to go here that I'm going to divide by 300 then? Just type it into the comments. What number And we can use the calculator for this one. What number am I going to divide by 300? Just type it in. What number did we just use? What number did we just come up with? We did all this work. Good. 609. We're going to type 609. Again, I said it was okay. We're going to use the calculator for this. 609. We're going to divide it by 300. Because that's how many square feet each gallon would cover. And we get a decimal answer. 2.03. So, I'm just going to write that here. 2.03 gallons. It says, find the number of gallons of paint needed. So, if I need 2.03 gallons, think about this before you just put anything in there. Okay? If I need 2.03 gallons for my paint job, how many gallons of paint do I need to buy? Okay. Okay, good. 2.03 gallons is what I need. Okay. But remember, you can't buy fractional amounts of paint. Okay, well, let's not speak up for people that, are asking me to slow down. We're not going to talk about other people in our class. Okay, remember, if people need more time with the information, you can re-watch these videos over and over and over as many times as it'll take you to understand it. You can ask questions. You can go to Ms. Mixon's lives. There's lots of ways to get help, okay? So, yes, ma'am. Okay. I've got one of our new students that has the right answer. The question was, if you need this much paint to paint your room, 2.03 gallons, that's more than 2 gallons. My question was, how many gallons of paint do I need to buy? How many do I have to purchase? I can't purchase a fractional amount. I can't purchase 0.03 of a gallon. So how many gallons do I need to buy? Good. Now people are getting it. Thank you. Thank you. Yes, if I'm going to paint a room that requires 2.03 gallons of paint, I have to buy 3 gallons of paint. Because if I only buy 2 gallons of paint, part of my room isn't going to get painted. Good job. It's 3. The answer is 3. This is similar to those questions about, we did these with like school buses, and one of the fractional problems they love to give us was how many school buses did we need for a field trip? If 20 kids fit on a bus, but we have 50 kids, how many buses do you need? And you would need 2.5 buses, and people would say, oh, well, then you're only going to have 2 buses. No, you would need 3 buses because we're not going to leave people behind. It's the same with this painting. I'm not going to just paint, whatever amount 2 gallons cover and leave a corner kind of messy and looking crazy, right? I want my room to look nice, and especially if I'm hiring a painter, which, that's a whole nother story. So this little guy that wants to estimate that he's going to buy me, 4 gallons of paint, now you can go to him and say, no, sir, I don't need 4 gallons of paint. It said show his estimate for the number of gallons is too high. We knew 4 was too high, but we didn't know how many we needed. Okay, so you would actually need 3 gallons of paint. So that was a great job. Especially shout out to our new student. All my avid students, I really need you guys to really be participating and get everybody to participate. Because remember, nobody's places are secure for next year. The evidence that you guys are, supposed to stay in avid is going to be your grades. So We didn't have our end of the year park test to use our scores. So the last page is your exit ticket. Okay, so I'm just reading it to you. So we have a couple minutes. The local school is building a new playground. The plan shows that part of the playground that needs to be framed with wood for the swing set. The unit of measure is feet. Determine the number of feet of wood needed to frame the playground. So they want you to figure out if you're framing something, okay, are you just doing the outside of it or the whole interior of it? So are you solving for perimeter or area? That's what they want you to think about. And then the second one, I guess this will answer the other part of the problem. Then they want to fill in the area that's enclosed with wood. Oh, sorry, that's enclosed with wood with mulch. You know, those little wood chips that make it safe. Determine the area in square feet that needs to be covered by mulch. So it looks to me, hint, hint, that you're going to be solving for both of those. Excuse me. In problems 1 and 2. Okay? And you're going to do 1 and 2. You're going to take a picture of whatever work you do. If this is my work, I'd snap a little picture and DM this to Ms. Martin because I want to get my grade. Okay? Doesn't have to be perfect. It just has to be show my work, show my answers that are circled. If it requires a sentence, you know, my sentence needs to be written out. Excuse me, just like we did in class all year. You know, that was kind of the disappointing part. Some of the packets people turned in, they had even like sentences they answered, but then didn't show any math. Okay? And remember, for your extra credit project, you're also going to work on this. I will let Ms. Mixon, she'll announce when that's due, in her class. Her classes are typically at 2:30 in the afternoon on certain days, but she and I will announce that. If you turned in your packets, I got them. Yes, ma'am, I got yours. Thank you. So, people will definitely see in the grade book if we've graded your work. There's comments that say grade, in my grade book, the comments section say grade was increased due to distance learning. Excuse me. And there's also 2 columns. One says distance learning work week 4 and week 5. It doesn't match what work we're doing, but that was the actual week time-wise that we were on. Excuse me. That was last week and the week before. And that has your points for things. Like the packets I graded last week, I'm going to check today and tomorrow on, I gave people through Friday for Khan Academy and iReady. Excuse me, and all that will count. Excuse me, now I'm coughing. So, I'll probably have new Khan Academy videos for this upcoming unit. So, sorry, I'm okay. I just have a tickle after talking to myself all this time. Thank you. If you have any questions, please let us know. It's okay if people just finish some of the packets. All the packets that you've turned in by Friday, I'll be picking the rest of them up tomorrow. The ones that were turned in by last week, I already picked up last Tuesday. I graded all of those. I left them in my classroom, but I graded them. Ms. Mixon's reminding you, you can pick up today the new packets from 10 to 2, or the rest of the week you can go to Blue and do that. I don't think we've ever finished this earlier on time in weeks and weeks and weeks. So please, please, please let us know if you have questions. You can DM us, text, email, call. People have been using all of those methods. And yep, if you turned in a packet before last Tuesday, then I've already graded those, and those grades are being put into, those grades are already in the grade book, but the grades that you did more Khan Academy and other things are also being put into the grade book this week, okay? Everything that we're doing on distance week 4 and distance week 5, and then what we finish after that for 6 and 7, that will all be on your 4th quarter grades, okay? And term 4 matters. Remember that, okay? All right, I love you guys. Miss you. Bye.